Out there, beyond the reach of sunlight, lies a universe filled with wonders so strange they defy everything we think we know. Stars that die yet refuse to fade, collapsing into spheres no larger than a city but heavier than mountains. Blinding beacons that burn brighter than entire galaxies, cosmic lighthouses guiding us through the darkness. Worlds that drift endlessly between the stars, and forces so powerful they can bend reality itself. From the impossible heart of a neutron star, to the blazing fury of quasars, to the silent wanderers the rogue planets lost in eternal night. This is not science fiction. This is our universe, mysterious, violent, and breathtakingly real. Welcome to Space Frontier Ventures. Join us as we journey to the edge of understanding, where the strangest objects in existence reveal the truth about the cosmos itself. Neutron stars are the remnants of massive stars that have ended their lives in spectacular supernova explosions. Imagine a star several times heavier than our Sun, collapsing under its own gravity until it shrinks into an object only about 20 kilometers across. Barely the size of a small city, but containing more mass than our Sunday. This makes neutron stars incredibly dense. Just a teaspoon of neutron star material would weigh billions of tons on Earth. These objects challenge our understanding of matter, compressing it to densities that cannot be recreated in any laboratory on our planet. What makes neutron stars so strange is not just their density, but their exotic nature. They are essentially giant atomic nuclei, composed almost entirely of neutrons, held together by gravity and quantum forces in a delicate balance. Their intense gravity bends light and warps spacetime around them, creating extreme environments where the usual laws of physics start to behave differently. The surface gravity is about 200 billion times stronger than Earth's, meaning if you dropped a paperclip on a neutron star, it would hit with the energy of a nuclear bomb. Some neutron stars are also known as pulsars, cosmic lighthouses spinning at incredible speeds. Due to their strong magnetic fields, they emit beams of radiation from their magnetic poles. As the star spins, these beams sweep across space, and if Earth happens to lie in their path, we observe pulses of light with astonishing regularity. Some pulsars rotate hundreds of times per second, showcasing the incredible power and angular momentum packed into these tiny, dense spheres. Beyond their physical extremes, neutron stars are laboratories for some of the universe's most mysterious phenomena. Their cores may contain exotic states of matter, including superfluids or even quark-gluon plasma, forms of matter that only exist under such extreme pressure. Observing them allows scientists to probe physics that is otherwise inaccessible, helping us understand the behavior of matter, energy, and gravity under conditions far beyond earthly experience. Neutron stars are reminders of both the beauty and strangeness of the cosmos. Born from stellar death, they are among the universe's most extreme objects, yet they continue to reveal secrets about the fundamental laws of nature. Their tiny spinning bodies carry clues about star formation, supernova mechanics, and the mysterious interiors of matter itself, truly making them one of the strangest and most fascinating objects in existence. Quasars, the brightest beacons of the universe. Quasars are some of the most luminous objects in the universe, outshining entire galaxies despite being only the size of our solar system. At their core lies a supermassive black hole, millions or even billions of times heavier than our Sun, greedily consuming gas, dust, and stars that venture too close. As this material spirals into the black hole, it forms an accretion disk, heating up to incredible temperatures and emitting staggering amounts of energy across the electromagnetic spectrum, from visible light to X-rays and even gamma rays. The result is a cosmic lighthouse, visible billions of light years away, marking the location of some of the earliest and most active galaxies in the universe. What makes quasars truly fascinating is the scale of their power. Some quasars radiate more energy in a single second than the Sun will emit over its entire 10 billion year lifetime. This intense output is not uniform either. It fluctuates, flickers, and sometimes erupts, giving astronomers clues about the behavior of the black hole at its heart and the environment around it. The study of quasars allows scientists to peer back in time, observing the universe as it was billions of years ago, when galaxies were still forming and evolving. Quasars also challenge our understanding of physics in extreme conditions. The gravitational forces near the supermassive black hole are so strong that they warp space-time and bend light, creating relativistic effects that astronomers must account for. Magnetic fields twist and channel jets of plasma from the quasar's poles, shooting streams of charged particles across intergalactic distances at nearly the speed of light. These jets can influence the formation of stars and the growth of galaxies, showing that quasars are not just bright, they are powerful cosmic architects. Despite their brightness, quasars are distant and mysterious. Many of them existed when the universe was only a fraction of its current age, meaning the light we see today has traveled billions of years to reach us. Observing them is like peering through a time machine, witnessing the early universe in its formative stages. Each quasar is unique, with its own behavior, energy output, and environment, providing astronomers with a laboratory for studying extreme astrophysical processes on a scale impossible to replicate on Earth. Quasars are more than just cosmic beacons, they are windows into the infancy of the universe, markers of black hole growth, and engines that shape the cosmos itself. Their brilliance, power, and distance remind us of the vastness of space, the mysteries yet to be unraveled, and the astonishing extremes that exist in the universe. They stand as one of the most spectacular and enigmatic phenomena ever discovered, a testament to both the creativity of nature and the curiosity of humankind. Magnetars, the most dangerous stars ever discovered. Magnetars are a rare and extreme type of neutron star, but unlike typical neutron stars, they are magnetic monsters. Their magnetic fields are so intense, trillions of times stronger than Earth's, that they can distort atoms, twist space, and even affect electronics across thousands of kilometers. Born from the collapse of massive stars, magnetars are small, dense, and incredibly compact, just about 20 kilometers in diameter, yet containing more mass than our Sunday. This combination of density and magnetic fury makes them some of the most violent objects in the universe. What sets magnetars apart is the sheer power of their magnetic storms. The energy stored in a magnetar's field can be released in sudden bursts, known as soft gamma repeaters or X-ray flares, which can briefly outshine all the stars in their galaxy. These flares are so energetic that if one were to occur within a few light years of Earth, it could disrupt satellites, knock out power grids, and even damage the ozone layer. Magnetars are cosmic ticking time bombs, their calm appearance belying the latent energy waiting to erupt. Magnetars are also extreme laboratories for physics. In their intense magnetic fields, matter behaves in ways impossible on Earth. Atoms are compressed and stretched, light bends, and even the vacuum of space becomes polarized. Studying these stars allows scientists to explore the limits of quantum mechanics, relativity, and nuclear physics, all in one celestial experiment. Despite their danger, magnetars give humanity a rare glimpse into conditions that challenge our understanding of nature itself. Interestingly, magnetars are not permanent threats. Their magnetic fields decay over tens of thousands of years, a blink of an eye in cosmic terms, releasing energy in dramatic, sometimes unpredictable ways. Astronomers track these eruptions using space telescopes sensitive to X-rays and gamma rays, capturing flashes that last from a fraction of a second to several minutes. Each burst offers clues about the structure, rotation, and environment of the magnetar, piecing together a picture of one of the universe's deadliest yet most fascinating objects. Magnetars embody the paradox of cosmic beauty and danger. Tiny, dense, and seemingly fragile, yet capable of releasing more energy in a single flare than the sun will in 100,000 years. They are a reminder that the universe is full of extreme. They ignite our curiosity, challenge our theories, and prove that even in the darkest corners of space, there exist objects of staggering power that are as captivating as they are terrifying. Rogue planets, worlds lost in the darkness. Rogue planets are the loners of the cosmos, wandering through space without a star to call home. Unlike the planets in our solar system, which revolve predictably around the sun, rogue planets drift through the galaxy in total darkness, untethered by any gravitational anchor. They could have formed around a star and been ejected by a cosmic collision, or they might have formed alone from collapsing gas clouds, never attached to a stellar family. Imagine a planet-sized wanderer, cold and isolated, gliding silently through the void, carrying the secrets of its mysterious past. Despite their loneliness, rogue planets are fascinating laboratories of physics. Without the light and heat from a nearby star, their surfaces are incredibly cold, sometimes dipping below -200 degrees Celsius. Yet, some rogue planets may have internal heat left over from formation or radioactive decay, possibly allowing subsurface oceans to exist, hidden beneath thick layers of ice. These hidden oceans could, in theory, harbor life in conditions radically different from anything on Earth, reminding us that habitability doesn't always require a sunny sky. Detecting rogue planets is a monumental challenge. They don't emit light like stars, and without orbiting a sun, they are invisible to conventional telescopes. Astronomers rely on indirect methods, like gravitational microlensing, where a rogue planet's gravity bends light from distant stars, briefly revealing its presence. Every detection adds to the growing realization that the galaxy may be teeming with these dark wanderers, possibly outnumbering the stars themselves. Each discovery tells a story of formation, ejection, and survival in the lonely void of space. Rogue planets also offer a glimpse into the violent nature of planetary systems. Their existence hints at the chaotic early days of star formation, where gravitational interactions can hurl worlds into interstellar space. Some of these planets may carry atmospheres, magnetic fields, or even moons, making them miniature, self-contained worlds on a journey through the cosmos. Observing them challenges astronomers to rethink what a planet really is, and what it means to exist in the universe without a sun. In the end, rogue planets are both haunting and awe-inspiring. They wander alone in darkness, yet they embody the resilience and mystery of planetary formation. They remind us that the universe is far stranger than we imagine, filled with worlds that defy expectations and continue to wander, silent and unseen, through the infinite expanse of space. White holes, the opposite of black holes. White holes are one of the most mysterious and mind-bending ideas in astrophysics. If black holes are regions of space where nothing can escape, white holes are theorized to be the exact opposite regions where nothing can enter. Imagine a cosmic fountain, endlessly spewing matter and energy, but completely impervious to anything trying to fall in. They exist in theory as a solution to Einstein's equations of general relativity, but no one has ever observed one, making them almost like ghosts of the universe, hinted at by mathematics but unseen by human eyes. The concept of a white hole challenges everything we think we know about space and time. While black holes trap everything including light inside their event horizons, white holes would repel everything, ejecting material into space. Some physicists even speculate that white holes could be linked to black holes through a wormhole, creating a tunnel from one part of the universe to another, or even into another universe entirely. In this scenario, a black hole could swallow matter on one side, while a white hole spits it out somewhere else, a cosmic recycling system beyond imagination. Despite their intriguing theoretical properties, the existence of white holes remains purely speculative. Observing one would be almost impossible, because if they exist, they would be incredibly rare and might only appear for brief moments. Some scientists suggest that certain gamma-ray bursts or mysterious cosmic phenomena could be the signature of white holes, but nothing is conclusive. They remain a tantalizing hint that the universe may have structures even stranger than black holes. White holes also provoke deep philosophical questions. Could they represent the birth of matter or energy? Are they remnants of the Big Bang, or the seeds of new universes waiting to be discovered? If a white hole were ever detected, it would force humanity to rethink the nature of space, time, and causality itself. They are a reminder that the universe is not just a passive backdrop for our existence, but a place of active, sometimes inexplicable phenomena. In the end, white holes capture our imagination because they exist at the edge of possibility. Whether they are real or just mathematical curiosities, they push the boundaries of what we consider possible, inspiring both awe and wonder. They remind us that for every cosmic truth we uncover, countless others remain hidden, waiting for the brave and curious to chase them into the depths of the unknown. Pulsars, the cosmic lighthouses of the universe. Pulsars are among the most mesmerizing objects in space, acting like cosmic lighthouses spinning in the vast darkness. Born from the collapse of massive stars in supernova explosions, these neutron stars pack more mass than the Sun into a sphere barely 20 kilometers across. Imagine a city-sized object with the density of Mount Everest squeezed into every teaspoon. This is the world of a pulsar. Their magnetic fields are so intense that they create beams of electromagnetic radiation shooting out from their poles, sweeping across the universe like the beam of a lighthouse across the ocean. What makes pulsars extraordinary is their precision. As they spin, these beams of radiation pulse at incredibly consistent intervals, some rotating hundreds of times per second. From Earth, these pulses appear like a rhythmic beacon, allowing astronomers to use them as cosmic clocks. In fact, some pulsars are so precise that they rival atomic clocks on Earth, making them vital tools for measuring gravitational waves, testing Einstein's theories, and even navigating spacecraft across the solar system. Despite their tiny size, pulsars hold incredible energy. Their rotation slows over time, but the amount of energy they release in the form of radiation is staggering. A single pulsar can outshine an entire galaxy in certain wavelengths, and their rapid spin and magnetic fields can accelerate particles to nearly the speed of light. This makes them not just fascinating, but also some of the most extreme natural laboratories in the cosmos, where physics reaches limits impossible to replicate on Earth. Pulsars also come in extraordinary varieties. Some are millisecond pulsars, spinning hundreds of times per second, often as a result of stealing material from a companion star. Others are magnetars, where the magnetic field is so strong it could wipe the data off a credit card from 1,000 kilometers away. Each pulsar we discover adds a new chapter to our understanding of stellar evolution, extreme physics, and the mechanics of the universe itself. In the end, pulsars are more than just spinning stars. They are cosmic metronomes, marking the rhythm of space-time. They remind us that the universe is alive with motion, energy, and signals that stretch across light years, and that even in the darkness of space, there are beacons guiding humanity's understanding of the cosmos. High above the stars, beyond the reach of our atmosphere, the universe occasionally flashes for just a few seconds with a light so intense that it can outshine entire galaxies. These flashes are called gamma-ray bursts, or GRBs. They are the most violent and powerful explosions the cosmos has ever produced since the moment of the Big Bang itself. For a long time, astronomers didn't know what they were. The first GRB was discovered by accident in the late 1960 seconds, when US military satellites, designed to detect nuclear tests, picked up mysterious bursts of gamma radiation not from Earth, but from deep space. At first, no one could explain them. They appeared without warning, lasted only seconds, and vanished just as quickly. But their power was unimaginable, a single burst, releasing more energy than our sun will emit in its entire lifetime. Today, we know that most gamma-ray bursts are born from death, the catastrophic collapse of massive stars. When a star many times larger than our sun reaches the end of its life, it explodes in a supernova, its core collapsing into a black hole or a neutron star. but in some rare cases, the collapse channels all that energy into narrow beams of radiation that shoot out at nearly the speed of light. If one of those beams happens to point toward Earth, our telescopes catch it as a gamma-ray burst. Other GRBs are even more extreme. They can form when two neutron stars collide, merging in a blinding explosion that warps space-time itself. These events are so powerful, they can create gold, platinum, and other heavy elements, scattering them across the galaxy, the very materials that later form planets, jewelry, and even parts of our own bodies. In a sense, every GRB is both an ending and a beginning, a cosmic forge where new matter is born from destruction. If one were ever to occur close to Earth, within our galactic neighborhood, the results could be catastrophic. The gamma rays could strip away our atmosphere and destroy life. Thankfully, these bursts usually happen billions of light years away, far enough for us to watch in awe rather than fear. Each one is a distant reminder of how fragile and how connected we are to the violent heart of the universe. The universe is stranger, brighter, and more dangerous than we could have ever imagined. From the dense spinning cores of neutron stars to the explosive fury of gamma-ray bursts, from wandering rogue planets lost in the dark to the enigmatic mysteries of white holes, the cosmos constantly reminds us how much there is yet to discover. Even the brightest quasars and the deadly magnetars teach us that the universe is a place of extremes where life, light, and energy exist in forms we are only beginning to understand. And yet, in all its chaos and beauty, the cosmos invites us to keep looking up, to keep asking questions, and to never stop exploring. We may never reach every corner of space, and we may never fully understand every phenomenon, but the thrill of the search, the joy of discovery, and the awe of witnessing the unimaginable are what make this journey so extraordinary. So, from the spinning lighthouses of pulsars to the cataclysmic power of gamma-ray bursts, remember, every star, every planet, every burst of energy tells a story. And the universe, in all its vastness, is still waiting for us to read it. Until next time, keep your eyes on the stars and your curiosity burning bright. This has been Space Frontier Ventures, exploring the impossible, one cosmic wonder at a time.